So hello and welcome to this lesson. This is going to be on physics. We'll be looking at dimension analysis part 2. We've already looked at part 1 in our previous lesson. In this lesson we'll be looking at dimension analysis with respect to the general gas equation P V T equals to K. So we're going to look at the values that the powers x, y, and k, the values that we take for p raised to power x, v raised to power y, t raised to power k equals constant to be Boyle's law, Charles' law, and pressure law. At different instances, depending on the values of x, y, and z, this general gas equation can become Boyle's law or Charles' law or pressure law. So that's what we'll be looking at right now in this lesson. So what are the values that x can take? X is actually going to range from x, y, and z can actually be -1, 0, or 1 depending on the equation at hand. So we're going to look at what values it's going to take actually. It can be 2, it can be 3, it can be -2, it can be -3, but it can be -1, 0, or +1. So now we're going to start with Boyle's law. So for Boyle's law, so for Boyle's law actually states that the pressure of a fixed mass of gas is inversely proportional to its volume. It's inversely proportional to its volume. The pressure of a fixed mass of gas is inversely proportional to its volume. So we're going to depict that mathematically. Boyle's law is P inversely proportional to IV. So right now we're going to introduce an equality sign. When we introduce the equality sign and do away the proportionality sign, we have to bring in the constant. So our constant is going to be K. So Boyle's law is that the pressure is inversely of a fixed mass of gas is inversely proportional to the volume at constant temperature. So our constant is K. This is at constant temperature T. So the Boyle's law is that the pressure of a fixed mass of gas is inversely proportional to the volume at constant temperature. Okay, so this is the mathematical expression. P is inversely proportional to volume. Now we do away with the proportionality sign and we are going to introduce an equality sign. So we're going to bring a constant. We're going to use letter K to represent our constant. So the next step is that P is equals to the constant K times IV. Okay, so this is it. So right now K times 1 is K. V moves up here to cross multiply to the left hand side. So P times V, you have PV. So V goes up here and multiplies P, you have PV equals to K times 1 gives you K. So PV is equals to K. Okay, so this is Boyle's law. PV is equals to K. P inversely proportional to V. P equals to K over V. So PV is equals to what? K. Okay, this is the same thing as P is equals to K all over V. So K becomes the subject of the formula. PV is equals to constant. This is Boyle's law. P times V is equals to constant. So now, from here now, we have P, we have V, just like we have O. Our question was from here, PV, T, P raised to power X, V raised to power Y, and T raised to power K equals to constant, which is our constant is actually K. So let's replace the constant with K. That if P raised to power X, V raised to power Y, T raised to power K is equals T raised to power Z is equals to K. What are the values that they will take? Values of X, Y, and Z to make it Boyle's law. So right now we have that PV is equals to K, but there is no T here over here. So we are going to introduce that T. We are going to what? Introduce the T. Okay. So you have P, V. Now let's multiply this by 1. When you multiply something by 1, it doesn't alter the value. So this 1 is representing the T we want to introduce. So we have PV times 1 equals to K. So now, from indices, when you raise 2 to power 0, 2 raised to power 0 is what? 1. 100 raised to power 0 is equals to what? 1. 100 raised to power 0 is what? Equals to 1. Anything raised to power 0 is 1. That means that temperature T raised to power 0 will give you 1. So to introduce T into this equation, I first of all brought in 1, which does not alter the value anyway. PV times 1 is still PV. So right now, what do? In place of the 1, T raised to power 0 is 1. So I replace 1 with T raised to power 0. So at the end of the day, we have P, V, T raised to power 0 equals to K constant. So let me rub off the board. So at the end of the day, we have P, V, T raised to power 0 equals to K. Now, what is the power of P? The power of P is 1. What is the power of V? The power of V is 1. Since they're not carrying any power, any index, the index there is 1. From your mathematical knowledge, you know that any variable or number that doesn't carry power, that the power is automatically 1. So that of T is 0. So this is actually Boyle's law. P raised to power 1, V raised to power 1, and T raised to power 0 equals to K. So X is equals to, if we compare this with this now, P raised to power 1, V raised to power 1, T raised to power 0 equals to K, with P raised to power X, V raised to power Y, T raised to power Z equals to K. Our X is 1, our Y is also equals to 1, and our Z is equals to 0. Okay, our Z is what? Equals to 0. So our equation is solved. So for P raised to power X, V raised to power Y, T raised to power X equals K, which is constant. This is the general gas equation. For it to be Boyle's law, then X must be 1, Y must be 1, and T must be raised to power 0. So that is done. We're going to move to the next one. It's as simple as that. So we're going to move to the next one, which is Charles' law. For Charles' law now, Charles' law is still the same question, but now what are the values that X, what are the values of X, Y, and Z for this general gas equation to reduce to Charles' law, for it to be Charles' law? So we are going to solve that right away. So for you to easily solve these problems, you must know the law. The law must be in your head. So what is Charles' law? Charles' law states that the volume of a fixed mass of gas is directly proportional to its temperature at constant pressure. So mathematically, the volume V of a fixed mass of gas is directly proportional to its temperature T at constant pressure P. So mathematically, this can be written as V directly proportional to T, and next we'll bring in the constant of proportionality. This is at constant P. So we bring in the equality sign. Our constant is still K, just like before, constant K. When you bring in the equality sign, you have to introduce a constant. So V is equals to what? Constant K times T. So we have V is equals to KT. This is the constant K. Then with the T, they are multiplying themselves. This is KT, K times T, KT. So this is V is equals to KT. This is actually our Charles' law. So we're going to make V the K the subject of the formula. So that means T is going to come down. So you have T, it comes down here in the denominator. So you have V over T is equals to what? K. So this is a different version of this is Charles' law, this is Charles' law. Okay, here we'll make K the subject of this equation. So from here now, we can say that V is raised to power 1, T, okay, V, then this T can come up. Okay, before we even bring it up, V here is power 1, T here is power 1. Okay, V what? This is power 1, this is power 1 as well. So from indices, when you have a positive power in the denominator, if you take it to the numerator, it's going to become negative. So this plus 1 here, which is plus 1, when it goes up, this thing can goes up, it's going to become minus 1. So you have T raised to power minus 1. You have T raised to power minus 1. Okay, so you have V raised to power 1, T raised to power minus 1 equals to what? K. Okay, so you have V raised to power 1, T raised to power minus 1. So just like before, in this equation right now, the original equation was that the general gas equation is P raised to power X, V raised to power Y, and T raised to power Z equals to K equals to constant. So in our expression for Charles' law right now, there's no P. How do we bring in P? Just like before, we can actually introduce 1 here. So you have 1 times V raised to power 1, T raised to power minus 1 equals to K. So this one now, from indices, when you raise something to power 0, it gives you 1. So we can say P raised to power 0 is equals to 1. So we can replace this one with P raised to power 0. So we have P raised to power 0, V raised to power 1, T raised to power minus 1 equals to K. Okay, so this is the same thing as that. Okay, this was, let me write this properly. P raised to power 0 times V raised to power 1, T raised to power minus 1 equals to K. So this is P raised to power 0, V raised to power 1, T raised to power minus 1 equals to K, equals to constant. So for this is Charles' law. For Charles' law, P is raised to power 0, V is raised to power 1, t is raised to index minus 1, exponent minus 1. So over here right now, you can say that if you compare this and this now, x is what? 0, y is 1, t is minus 1. So at the end of the day, our x is 0, y is 1, and z is minus 1. So these are the values of x, y, and z. As simple as that. So, and I believe actually understood. In case you don't have any question, you can drop in the comment section, or you drop your question via WhatsApp. Thank you so much. So we're going to move to the next one right away, which is the pressure law. So what are the values of x, y, z for this general gas equation to become the pressure law? Just like before, it's going to be between 0, 1, minus 1 to finish. So we're going to work that out, but you need to know the pressure law. So what is the pressure law? You remember the pressure law? I hope you still remember the pressure law. So the pressure law is actually states that the pressure of a fixed mass of gas is directly proportional to the temperature at constant volume. The pressure of a fixed mass of gas is directly proportional to the temperature at constant volume. Okay? So like I said that the pressure law states that the pressure of a fixed mass of gas is directly proportional to its temperature at constant volume. So mathematically, that is P is directly proportional to T at constant volume V. So now I'm going to introduce a constant of proportionality. We have that P is equals to KT. Our constant of proportionality is K. Our constant of proportionality is what? K. So we make K the subject of the formula next. So this becomes that. This is going to come down below. You cross multiply, this comes down. So you have P over T equals to K. Okay. So from here, P raised to power 1 all over T raised to power 1 is equals to K. Then this T is going to come up. When it comes up, the power becomes negative. The power is plus 1 right now, but it's going to become minus 1. So you have P raised to power 1, T raised to power minus 1 equals to K. So the general gas equation is P raised to power X, V raised to power Y, and C raised to power Z equals to K. So, but there is no V in this equation. So just like I've explained before, for us to introduce, if I put V raised to power 0, V raised to power 0 is the same thing as 1. And if I multiply P raised to power 1, T raised to power minus 1 by 1, it doesn't change anything. So putting V raised to power 0 doesn't alter anything, because V raised to power 0 is the same thing as 1. If I add 1 here, not adding 1, if I multiply this by 1, it doesn't alter anything. So I can put P raised to power 1, V raised to power 0, V raised to power 0 is the same thing as 1. So it's just like I multiply by 1 by putting V raised to power 0. So, and T raised to power minus 1 equals to K. So this is pressure law. So your X is what? Your X is equals to 1. Your Y is what? Your Y is equal to 0. And your Z is equals to minus 1. So we've derived the equation for Boyle's law, for Charles' law, and for pressure law. We've gotten the value that of x, y, and z when the general equation, gas equation become Charles' law, become Boyle's law, and become the pressure law. So it is as easy as that. All you need just to do, just a little practice. Go over the video once again and try to painstakingly follow. If you have any problem, just chat me up either in the comment section or in via WhatsApp. But if you know you actually enjoy this video, I would like you to give us a thumbs up. I would like you to subscribe to the channel. I would like you to drop your comments, or if you know of a way we can actually serve you better, just drop it in the comment section and go ahead and like this video, just so that this video can actually be shared to a wider audience. Thank you so much for joining us. It's a pleasure. Bye. So in the next video, we'll still look at some applications of dimensional analysis and look at how we can actually apply dimensional analysis in some problems. So please watch out for the next video. Thank you so much.